Okay, hello Year 12. Today we're going to be having a look at the T formula, and this will correspond to exercise 17F in the Cambridge textbook. Now the formulas that we're going to have a look at today are given to you on the HSC formula sheet. So I'll just jump over and show you where those are. Okay, so these yellow ones here that talk about T being equal to tan A on 2, and the 3 sine, cos and tan A formulas are the ones that we're going to have a look at proving today. Okay, so where they sit on your HSC formula sheet is they sit on that second page underneath your trig functions and your trig identities, and underneath our compound angles is where they sit. So they are extension only formulas, and let's look at how we can derive those formulas. So although they're given to us on the HSC formula sheet, we still need to know how to derive them, because theoretically they could ask us to derive them, and we have to know how to get from one particular formula to another anyway. Okay, so here's our first one. It's called the T formula, and we're saying that T is equal to tan A on 2. A is just an angle. You could pop theta in there if you like. Then tan of A is equal to 2t over 1 minus t squared, and that's the rule that is given to you on your formula sheet. And we'll highlight that one in yellow as well. Okay, so what we want to have a look at now is proving that this is the case, this identity. Now we know from what we learnt previously up above with the double angle rule, the double angle rule says that tan of 2a is equal to 2 tan of a over 1 minus tan squared of a. Now this is for 2a. Now if I halved my 2a to get a, then I can halve my a to get a over 2, and that's what I'm going to do. So I've got then that tan of a is equal to 2 tan of a over 2 over 1 minus tan squared a over 2. So I've basically just halved all my angles. And then I'm saying, or I could say it up here, or I could say it down here, I'm going to let t equal to be tan a over 2, and therefore, wherever I have a tan a over 2 on my formula, I'm going to exchange that to be a t. So I'm going to end up having 1 minus, sorry, not 1 minus, is it going to equal 2t over 1 minus t squared. So my tan a over 2 has just been replaced by the t, and that is the rule. So that one's fairly simple. The cos and the sine are a little bit more difficult. So again, given that tan a over 2 is equal to t, we want to show that cos of a is equal to 1 minus t squared over 1 plus t squared. It's given to us on our formula sheet, but we need to understand where it comes from, because we're going to be asked questions about it and how to work with it. Okay, the double angle rule says that cos of 2 of a is equal to cos squared of a minus by sine squared of a. So like what I've done above, I then have said, well, 2a gives me a. So if I just halve my angles, a is going to give me a on 2. So I'm going to write it as cos of a is cos squared a on 2 minus sine squared a on 2. Then what I've done, and there's other ways to do this. You could use this with a triangle. I'm going to do it this way. This is the way the textbook does it. It's a couple of little tricks, but that's the way I want to do it. But if you want to go and look up some other ways to work this one out, you could as well. So I need to go and find some other way to write this. Now, cos of a being cos squared of a over 2 minus sine squared a over 2, I could write that or think of that. And if I just scroll over to the side, I'll show you what I mean. I could think of it as cos squared a over 2 minus sine squared a over 2, and the whole thing's over 1. And this is a little trick. You know how there's often little tricks in extension. But we also know that sine squared theta plus cos squared theta is 1. So I could exchange that 1 on the bottom for sine squared theta plus cos squared theta. And that's what I've done here. I've just written it in terms of sine squared a over 2 plus cos squared a over 2, because as long as those two angles are the same, that's going to work for us. So that's what my identity has now become. And I know that I want to end up getting everything in terms of t, and t being tan a over 2. So I need to think, well, if I divide by cos squared a over 2, I'm going to end up with a 1. Yep, if I divide by cos squared a over 2 over here, I'm going to end up with a tan. So that's what I want to do. I want to divide everything by cos squared a over 2. So if I divide each of those 4 terms in there by cos squared a over 2, I'm going to end up with cos of a being equal to 1 minus tan squared a over 2 over 1 plus tan squared a over 2. If I let t equal to tan a over 2, I can write that as 1 minus t squared, 1 plus t squared. So the little trick you need to know sits over here. Okay, and it is not a little, I'm going to call it a little trick. It's not a little trick. Really, we're just replacing the 1 by a trig identity. Okay, third time round, we're going to do the same thing basically with sine and show that sine of a is equal to 2t on 1 plus t squared. Okay, again, that rule's given to us on the formula sheet, but we want to be able to work with it. So let's have a look at how we can do that. Pretty much the same way. Using our double angle rule, sine of 2a is 2 sine of a cos of a. I'm going to halve each of my angles to end up with sine of a being 2 sine a over 2 cos a over 2. Like I did up above, I'm going to replace, or think of that as being all over 1, and my 1 is going to be replaced by my rule that sine squared theta plus cos squared theta is 1. I'm going to replace it with sine squared, basically theta on 2, but my theta is a, cos squared theta on 2 is 1. That's on my bottom line here. Okay, I can do that because it doesn't change the value, it's equal to 1. I eventually want to get up to here, and this is in terms of tan a over 2. So I need to think, well, what can I do and divide each term by? It needs to be the same term to get to tan. So I've got a cos and a sine on the top here. I need to get it to a tan. So if I divide by cos, I'm going to have, actually I'm not going to divide by cos, I'm going to divide by cos squared a over 2. This sine will divide by one of those coses and go to tan. The other cos will divide by this cos here and it will disappear. So we're going to do that for each of our 4 terms. So what we will end up with is that sine of a is equal to 2 tan a over 2, and on the bottom line we'll get tan squared a over 2 plus 1. If tan is equal to a over 2, we're going to end up with sine of a being 2t on 1 plus t squared. So that's where the rules come from, and they're fairly sensible when you look at them that way. Okay, so let's scroll down. I'm going to find the exact value of 2 tan 15 over 1 plus tan squared 15. So when you look at something like that, hopefully you're realizing that the format of it looks like a rule that you do know. So you're going to be looking at your HSC formula sheet. Just jumped out there. But I've actually got the wrong rule written down there. I've got that tan of a is 2t1 minus t squared, but we've got 1 plus t squared. So what's that going to be equal to? So let's go and have a look back at the rules that we know from our HSC formula sheet. And that looks more like this one up here, doesn't it? Which is sine of a. So just be really careful that you're looking back at that sheet to get the right value. Okay, so if a over 2 is 15, a is going to be 30. We want sine of that 30, so we want to work that out exact value-wise, special triangles, and we're going to have half as our answer. Okay, next one. Next one's a proof one. Okay, so whenever we're looking at proving, I want us to try wherever we can to start with the left-hand side and work our way down to get to the right-hand side. And sometimes you might do it the other way around. Sometimes you might start at the right-hand side and work to the left-hand side. But we want to get that kind of system going. We don't want to play around with both the left and the right-hand side at once and jiggle one from one to the other. Okay. So if I'm proving that and we'll call this is phi, I'm going to call him theta. We're going to prove that cot theta on 2 minus 2 cot theta is equal to tan theta on 2. Now, you're probably going to get a little bit stressed and confused with that to start with because we're only early days with these questions. But let's see what we can do. Okay, so starting with the left-hand side, cot theta over 2 minus 2 cot theta. What do we know about that? Now, I'm thinking that eventually we want to get to tan, and we've got cots. So let's write these cots here in terms of tan. Okay, so cot is 1 over tan. Tan is 1 over cot. So we've got cot theta on 2, sorry the little square keeps flashing up, is 1 over tan theta over 2. I'm changing my 2 cot theta to 2 over tan theta. Okay, so I've just gotten rid of my cots and written them as tans. If I let t be equal to my half angle, tan theta over 2, I'm going to replace that in that question. So I'm going to have 1 over t minus 2 over tan theta. Now, if we think back to our formula sheet, what was tan theta equal to? Tan of theta was equal to 2t over 1 minus t squared. Okay, I've got it down there. So we're going to, we'll leave it in there twice. So what we're going to do is replace our tan theta here with our tan theta here. So I'm replacing that and popping it in as 2t over 1 minus t squared. So my left-hand side of the equation is 1 over t. My right-hand side is minus 2, and I'm going to times that by the reciprocal. Okay, so when we're dividing by a fraction, we multiply by the reciprocal of that fraction on the bottom. The 1 minus t squared goes to the top. The 2t stays on the bottom. I already have a 2 on the top, so my 2's will cancel. I end up with 1 minus t squared over t. They're both over t, so I can pop them both over t. My top lines join. It's 1. That minus needs to go through to both of my terms in the brackets. So it becomes minus 1 plus t squared. The t's will cancel. The t squared cancels with the t to give me a t, which is tan theta on 2, which is my right-hand side. So it's just a lot of algebra, really, isn't it? So those are the notes for that section. But what I want you to do is to go and work through the exercises, and note that I will have some questions in the OneNote where I've normally done lots of the working out for the questions as well.